Welcome back, everyone. So in the last section, we talked about negative engineering and workflow orchestration. And now we're going to look more into Prefect and do some preparation in order to bring our previous work into Prefect. So to introduce Prefect, Prefect is an open source workflow orchestration open source workflow orchestration framework. We currently have over 9,000 GitHub stars, and our Slack community, which I'm responsible for managing as well, has over 17,000 members. Even if you're not interested in using Prefect today and you just want to talk about best practices or data engineering or workflow orchestration, and you have questions, feel free to come in. Everyone is definitely welcome to join in and participate. Prefect is Python-based and built to support the modern data stack. Specifically, for example, when I say modern data stack, I'm talking about the PyData ecosystem. So for example, we have a native Dask integration, so you can run your tasks on top of Dask to massively scale things out. We have a very active community mentioned there in the Slack with the 17,000 Slack members. And there is something that you should pay attention to here, that Prefect, there's Prefect 1.0 right now, and there's Prefect 2.0. So if I say Prefect Orion, Orion is the name of 2.0. And we right now, the current state is that we had Prefect 1 for 3 years, and we decided that there needed to be massive changes to the architecture in order to support the dynamicism of data use cases, of the modern data use cases. And the Prefect 1 just could not support that, and that's why we moved to Prefect 2. And the reason it couldn't support that is because of the concept called the DAG. So in previous workflow orchestration tools, they require you to define your workflows as the static graph. So when I say DAG, we're talking about a directed acyclic graph. And basically, if you draw arrows between your steps, this is what the DAG looks like. So previous orchestrators would make it a requirement that you need to fix ahead of time all the steps possible that your flow can take. And then during execution time, with the use of like triggers and stuff, you can say, oh, don't execute this path and just execute this other part instead. But because of this DAG requirement, we found that a lot of times developers found themselves fighting the DAG, and it introduced a lot of friction. So Prefect 2.0, which was first announced in October and is now currently in beta, looks to redefine what's possible with workflow orchestration and make it more dynamic than ever, and make it really feel like you're just writing Python and letting your code and being minimally invasive into your code. Prefect Cloud and Prefect Server. So these will change a bit in 2.0 and 1.0. So if you have Prefect the framework, you normally code your flows, your workflow in Prefect, and then when you're ready to execute, use a backend. So cloud is when we host it, and server is when you host it. In today's course, we're also in the section, in this workflow orchestration section, you're also gonna experience deploying your own Orion instance, which is akin to server, and having that live on your own infrastructure, on your own AWS VM, fully for free. But also I'll mention how cloud can make some of that things easier, some of the workflow orchestration components easier for you. So the current state of Prefect, if you hear the word core just refers to 1.0 and Orion refers to 2.0. Again, Orion is in beta right now. If you need something production ready literally today, 1.0 is available. But moving forward, you will find that using Prefect 2.0 allows for a richer set of use cases and has a lot less boilerplate code. So just to give a flavor of what Prefect 2 looks like, for example, this is the basic hello world. Here we have a task and a flow decorator, and that's all the Prefect dependency here. So this is just a normal Python function. It just gets the stars for a GitHub repo. This is a normal Python function as well. We give a list of repos, and for each repo, we just call this get stars function. And now you can just call the flow like this. We're going to dive in later what wrapping it in a decorator does. But in this hello world example, you can already see that you're really just writing Python code and then wrapping this task. And notice here you get retries for free, as I mentioned earlier in the previous section. All you have to say is retries equals 3, and now this task, this API call, if ever it fails, it has automatic retries associated with it. On the other, the flow also does provide some observability into what's happening, and I'll show you what kind of logs are added later when we dive into the prefect section. But this is just to give a basic preview of what prefect looks like. So now what we're going to do is we're going to take the IPython notebook that was worked on in the previous section, and we want to bring that to a Python script so that we can actually deploy it. Because the problem is that the notebook itself was one, hard to work with, and two, can't really be deployed. If we deploy it, it's deployed as a single step, but we want to break it up into smaller components so that we can get observability around each component later. And it's also best practice so that you can unit test your code. So over here in the repo, you're gonna find that there is, I have two files. After this section, we're gonna add a bit more, but for now, there's this file called orchestration.py, and this is kind of like the final version of what we want to achieve. And the second file is this requirements.txt file. So note that if you do a simple pip install prefect, it will give you prefect 1.0. In order to follow along today, you really need to install 2.0. So specifically, the version I'm using is 2.0 B5. We're in beta right now, so we have a couple releases every now and then, but I think we're approaching, something more stable. So you can but for now, let's just say to follow along, just use prefect 2.0 B5 and pin your version. So now what we want to do is we want to get this notebook over here that was worked on in the previous section. It's kind of ugly to work with on GitHub because of this like traceback. So what I'm gonna do is I'm gonna open VS Code, and I will move over to make a Jupyter notebook, and we're going to this experiment tracking. You may find, so what I need to do is I just need to copy all of this into the VS Code into a script. So I'll make a script, and then we can work on it here. I will do this live just so you get a feel for what I'm going to do. But if you want to do it yourself and you don't converge to like an exact solution, no problem. There's probably many ways to refactor this. The important part is just that you break it up into modularized functions that we can then use later. So I will make a new file, and I'll call this let's call it ML model training. Okay. So now we have this empty script, and I'm gonna just copy stuff over one by one. Should be no surprises here. And then from here, we'll edit it to break it up into separate functions that we can wrap tasks around, and then we can eventually call them in our flow. This is a very standard data science code, I would say, and you're gonna run into this a lot, especially if like you're in a setting where you are responsible for deploying data science code, and then they hand something over like this to you. You're probably used to this by now. This happens quite a bit. I would say though that there's some awkwardness to wrapping data science code after the fact, and we'll probably run into this as well. Primarily, there's like a lot of reliance on like global variables, which are not good practice. And global variables makes things hard to break up. So this autolog section, I'm not gonna bother with. I don't think this is important in our workflow. For our workflow today, we're primarily interested in just number one, maybe a simple model training, and then number two, like the hyperparameter grid search, right? So we're interested in those two main things. So this autolog thing, I'm not too concerned about. I'll bring these imports to the top just in case there's any other thing that needs them. We'll bring it here. We don't need any of the plotting because we now have a script and it's not interactive, so we don't need the plotting tools. I will just compress this import line. That's right. VS Code is telling me that these ensembles are not used. So I'll just take them out for now, take out the linear SVR. We probably don't need it since it's not used. And then now we have our first function, this read data. And okay, so this is just reading a CSV and doing some transformations on it. And then it gets applied to get DF train and DF val. And then further transformations are done on DF train and DF val. We have the Dick vectorizer, it gets fit transformed, and then we pull out Y train. And then here, this is already modeling. So this is where I'll break things up. And I'm gonna say that this is the modeling section. Now we need to refactor everything above that. So what I'm gonna do is I'm gonna make a new function, and I'm gonna say add features. And add features, notice this is hard-coded. Eventually, we want to make it parameterizable so that whenever we run this on the schedule, like every week or every month, we can easily just change the file name. I downloaded these data sets as well to test them, but I downloaded the Parquet file already. I know this is a very recent where they went from CSV to Parquet in order to compress the file size. I don't need this notebook. In general, just a word of advice, like Parquet is indeed a lot better than CSV. Number one, it's around 1/4 the size, 1/5 the size of this CSV. So there is some compression there. But more importantly, is that it actually holds, actually, I will make this a variable here. But more important with the Parquet is that it holds schema. So if you ever run into an issue where, like, for example, you're using a pandas date read.csv, and then like, oh, the date times are being read as strings and stuff, and you find yourself having to coerce them, then that's probably a use case to move to Parquet, because Parquet will hold schema for you, and it's a lot faster to load also. It scales to big data as well. These guys, this length train, DF train, DF val, I'll just make print statements around them. These are here because I assume that in the notebook setting, you're just trying to show how many the shape of the data frame. But here it won't print anything unless we actually specify print. And then we can move these out, move this. Looks like there's just some transformation, setting of categorical transformation. We can move this Dick vectorizer out, and then these guys should be out as well. And then from here, we can probably just return X train, X val, Y train, Y val. The Dick vectorizer is the hard one because this like tends to be like a global variable. I'll just return Dick vectorizer as well. It might be used later. And I set these as default variables to make it easy for myself to test this code. Everything looks right so far. Let's see what happens if we comment everything below and we just run it. So I'm gonna comment this. And now we can say add features. Yeah, I guess that's fine. And then we can just copy this and we can just go like this. And we might be able to just run this. Oh, I am in the wrong directory. Okay. I think so. This is because we specified a Parquet file, but here we're using CSV. So I think if we change this, this should work now. Yeah. And maybe I'll just, I'll just print something like print let X train, just to see that stuff was read. Oops. Okay, so that we got the print. Oh, that's the print inside. So that's this print. Sparse matrix. I think that's related to this length. Okay. Or maybe we can just do extrain that shape. Awesome. Okay. So we have it working now. It was just this issue here. And the next, let's keep going on to some code and see what more was done here. So we are now in the modeling section. I see that, so there was a linear regression, we fit it, we did our prediction, got some metrics, and then saved it out. And then in this section, this ML flow run is already separate. We did a lasso regression instead, and we logged in some artifacts. Over here, we have some XGBoost, and we have this objective function, which was used with hyper OPT, I think, right? Or up to hyper OPT. For here, what I'm gonna do is I'm not too interested in the linear regression models just because I think in practice, if you have bigger data, XGBoost tends to perform. So I think it's also not really relevant for this exercise because anyway, if you know how to do it for one model, you know how to do it for all. So what I'm gonna do is I'm just gonna comment this out first, this linear regression section over here. And then this ML flow start run. So what I'm gonna do is use the this one uses the XGBoost, so I don't need the lasso section. I think the lasso section is unneeded here. So this one is a bit just for another model. So I will do this. And now what we're gonna do is we're just gonna move these imports to the top. Just keep everything there. And then I'm gonna uncomment this I'm looking for the XGBoost specifically. So here, it looks like this was the lasso, and then here is where the XGBoost section starts. So I'm gonna uncomment. I don't need the auto logs onwards. I'm just gonna remove that. It doesn't really add much to bring that to workflow orchestration. So we have, oh, I think I deleted too much. There is this best model here. So I want to keep this. Yeah. Okay. So now we have two functions. We're going to break this up into two functions. The first one is the hyperparameter objective. So here, let's call this, we can keep this as is. What I'm going to do to make this clearer is like we have this going on, and I'll paste it here. And we have train, which will run on this, and then Y train. So this is good. And then over here, I am going to train search, model search. And I will move this under. So we have a function underneath this function, because what needs to happen is the ML flows section needs to see it. So I'm going to do something like this. And I think this might already work. In order to test it, max evals is 50. I'm just going to reduce this. I'm more concerned about just testing it quickly. And then from there, we can return. So in order to do this, I see that XGB train relies on params, relies on train, and valid. So I probably need to pass in train and valid that we set up here, right? And then aside from that, yval looks like it's needed as well. So I will try passing this. I'm gonna move this below as well. I'm just bringing everything eventually to a main function at the end. And then we can say train model search. And again, comment everything just so we can test to run. This is also pretty high. I want to just change it quickly so that we're not training a lot here while I'm testing. And I think that should be good. So let's try this. If stuff is going too fast or it's if it's hard to follow, I would say okay, everything worked fine. I would say it's okay, like no problem. The point is we just really need to get this into a Python script. If this is too dry for you also and it's like very easy, just I guess you can also, I will eventually upload this model training script. You could just pull that as well. And you don't need to go through this process. But I think this is also still an important part of the machine learning lifecycle, going through this, because I know a lot of people who have to do this as part of their work. Now I'm not sure if I need to disable this autolog. I'll just remove it for now. I will call this train best model. And we are going to uncomment everything. Same thing, I'm gonna get this thing that's forming and bring it at the bottom. And over here, we're going to uncomment this. I know this is from Christian's from the previous video where like he went into MLflow and got the best metrics. So that's an important so there's two ways you can do it in I'll just explain this some other in the next video. For now, I'm just seeing, okay, he had this best parameters, same thing, train valid, early stopping rounds. I can now increase this. It doesn't have to be 500. Can do 1000 now, set it to before. Awesome. Okay, so now I can do train best model. And then I can also wrap this in an if equals if name main. And if you're not familiar with the if name equals main, this just means like this code is only run if you call it with Python file name.py. Otherwise, it's if you import something in this file, this section won't run. And I hope both of these run. And if they both run, then we're ready to bring it to Prefect. I should have just probably lowered the iteration. I will quickly lower it right now, just so you don't have to wait for this to finish. We can end the video and then we can move on to the next one. So num boost round 100. Oh, that's just train best model. I just need to change the signature of train best model to something like this. And then I will just quickly change this back to 1000 for our actual production run. I'm looking if the dict vectorizer is needed anywhere. Okay, so we still write the dict. Actually, this will error out because we need to pass it in so that it's available here. And then pass it in. I think this just worked because we may have it globally defined. But I think we actually need to pass it in to be sure over here in this section. Okay, so now we have something working. In the next section, we're gonna discuss what our goal is by bringing it to Prefect, and we're gonna then discuss the basic features of Prefect and show what we can do by bringing this into a flow. I'll see you in the next section.